Hello, welcome to our video solution for problem 2 from my spring 2020 final exam. So here it looks like we just have a very simple integral. We could use the fundamental theorem of calculus, right? So we'd say, okay, what's an antiderivative? Let's see, that's going to be 7 over 2x squared minus 4x. Then we have to evaluate between negative 2 and 3. And let's see, at 3, we would get 3 squared is 9 times 7 is 63 over 2. Minus 4 times 3, okay, that's 12, which I could write as 24 over 2. Minus, okay, we evaluated at negative 2. Let's see, negative 2 squared is 4 times 7 is 28 over 2. And then 4 times negative 2 is negative 8, but there's another minus here, so positive 8, which I could think of as 16 over 2. And let's see, how many over 2's do we have? Let's see, 63 minus 24, that's going to be 39, minus another 28 of them. So 39 minus 28 is 11. And then minus another 16. So that should be like, negative 5 over 2? Hey, no problem. Okay, but there was like a whole paragraph up there before the problem. I mean, it can't say anything all that important, right? Let's see. Using the interpretation of integrals as accumulations, compute the values of the following integrals without, oh my gosh, without using the fundamental theorem of calculus. Oh man. Okay, so yeah, so like we totally used the fundamental theorem of calculus here, right? This was part 2 of it. Yeah, so we didn't follow the directions. All right. So we got to do this again. I mean, at least we have some sort of an answer. But is this good enough? No. All right, so what do we need to do? Well, we need to go back to, well, it says it right here in the beginning, our interpretation of integrals as accumulations, right? It's accumulating, right, some signed area. All right. So let's draw a picture. Let's draw a picture. I mean, we know what this graph should look like. It's a line, right? That's not too bad. So let's see here. We're going to need to go from negative 2 to 3. So how about put like negative 2 right there, and maybe a 3 can go over there. This could be our 7 x minus 4 axis. This could be our x-axis. Now let's see. When x is 0, we're going to get negative 4. So I can put a negative 4 in there. And then let's see. Well, I might actually want to know the endpoints too, right? So like, let's see, at x equals negative 2, I would get negative 14 minus 4 is negative 18. Oh my goodness, that's going to be way down here, right? So we're definitely not to scale. How about we readjust that? So that could be like negative 4, maybe negative 18 could be down here. And then at 3, let's see, 7 times 3 is 21, minus 4 is 17. So that could be up here. All right. And so then we just need a line now that goes through these I guess it would be through this negative 4 point now. And yeah, I don't feel very good about the way that's drawing. So let's erase it and just let the chips fall where they do. So at 3, maybe that's going to be about there. So I'll bring the 17 up a little bit. All right, so we just adjust our picture till it matches what we've drawn. Okay, so I get this this line. Now, what is the integral accumulating? Well, it's always going to be the area between the curve and the x-axis. So let's see, starting from negative 2, I'm going to be getting all of this stuff in between the curve and the x-axis, and it's below the x-axis, so I know it's actually some negative quantity. Now, once I get to whatever this point is, and of course we might actually want to know what that point is, then I know I'm going to be getting all the stuff again in between the line and the x-axis. So all this blue stuff, which I can see is going to be positive. So ultimately, my value should be the area of this blue triangle minus the area of the red triangle. All right, so the integral from negative 2 to 3, 7x minus 4 dx should equal the area of the blue triangle, okay, minus the area. And why is it minus? Well, because remember, it's red, right? It's below the axis. It's all giving us negative accumulation. So this is minus the area of this red triangle. Okay, well, computing areas of triangles is really not so bad, right? 1/2 the base times the height. So let's see. In order to get a base and a height, well, height's pretty easy here, right? Like here I can see this is negative 18, right? So the height, okay, is 18, right? So we kind of want to drop that negative there because that's what our height is. And now I want a base, which means I need this distance. So I really do need to know what that point is. So where does this curve hit the x-axis? That is, when is the y value 0? Well, let's see here. 7x minus 4. When does that equal 0? Well, we can add 4 to both sides and then divide by 7, and we'll get x is equal to 4/7. Okay, so we know that this coordinate here is 4/7. So the base is, well, how far do you have to go? You have to go 2 to get back to 0, and then another 4/7. So this entire base is 2 4/7, or since we're no longer in elementary school, we maybe write this as an improper fraction, so that would be 18/7. Okay, so the area of this red triangle is going to equal 1/2 the base, which was 18/7, times the height, which is 18. All right, how about the area of the blue triangle? Well, again, we know the height. Height is just 17. That's how far up to go to that point. And the base is, well, it starts at 4/7 and goes to 3. So this will be 3 minus 4/7. Now let's see, 3 is 21/7, minus 4/7 is 17/7. So this area is equal to 1/2 the height, which is 17, times, what would you say, 17/7. Okay, so let's see, 17 times 17, that's 289, over, well, let's see, we have over, I'm just going to maybe leave it as 2 times 7. I don't know, maybe it's a good idea, maybe not. I know it's 14, but let's see what we have over here. 18 times 18, that's 324. So minus 324 over 2 times 7. Let's see, 289 minus 324. Well, let's see, it takes 11 to get to 300, and then another 24 gives me 35. So negative 35 over 2 times 7. Yeah, look, that 7 there will cancel with a 7 in the 35. So I'll end up just with negative 5/2. Hey, that's what we had with the fundamental theorem. All right, so without the fundamental theorem, it really just comes down to something, you can solve using some elementary geometry, and hopefully this is helpful for having you solve these problems without using fundamental theorem of calculus. All right, take care.